In this video, I want to talk about the little thing or the concept in which we do not understand about the word friction. If we talk about friction, let me say the word friction. What do we call friction initially? You see, friction, the word friction is a force, but since we call it a force, which type of friction? The only explanation that I give to friction is that if a motion is going like this, if something is going like this, a motion is going like this, the force, another force is going to oppose it like this. This thing is called frictional force. This is the motion. It means that whenever we have an object that is going in any direction, a force is going to oppose it. That force is going to oppose it in the same direction, exactly opposite to that direction. That thing is called the frictional force. Let me give an instance. Let's say you are going forward. Something will be pulling it backward. We call it what? Friction. If something wants to go upward like this, an object wants to go upward, something that you want to like oppose, it is directly upward, we call it friction. But in most cases, friction, we call this one friction when it is on horizontal direction. But when it is vertical, what vertical means is along y-axis. When it is along the y-axis, we call it this one weight. They say that weight acts downward. Weight acts downward. So our W equals to what? mg. So that's why the unit is in what? Newton. We said friction is a force. Now, the unit of friction is also the unit of force, which is what? Newton. I hope you understand what I said. Now, let's now consider these motions along some path. The first case 1, motion along this path. Let's say this is a rope. They now say that this block is being dragged by this rope. This is going to be the tension in the rope. Tension in the rope. It means that if you want to calculate the resultant force of all this, like if you want to calculate the force of this block is going to have one force that's holding it. It's going to have a magnitude. It's going to have a magnitude. Magnitude is in one sense like say 5 kg. That's what magnitude is. This thing is going to have a magnitude. And what? An acceleration with which it's going to be moving. So this block is going to have its own magnitude of m. And the acceleration is going to be in direction, which is what? A. I hope you understand what I'm saying. If this were not to have a frictional force, if there is no frictional force here, it means that this T will be equals to ma. Also, tension will be equals to what? Tension will be in Newton. Tension N in Newton. You call this T equals what? Tension. In rope or string or what? Or cord and many other things. I hope you understand this. So if this has a frictional force, if this block that is moving, this block, if it has a frictional force like this, frictional force, this is a force that is pulling it. pulling or pushing it. If this has, this force is the one that is taking it to where it's supposed to go, but this one is frictional force that is more or less like opposing it. We said frictional force is the force that opposes motion. If this were to be the frictional force, if this is the force that is pulling it, like it is making it to move, and this is the frictional force, the moment this object, we talk about this to be rope. Now in a rope or a cord or a string, in a rope or a cord or a string, we have the tension T. I hope this is making sense. Now let's say they only talk about the tension. Now we are not now talking about tension. We are not talking about the force. This one I'm telling you is that this force is something that you must know that exists. It's only if you are being told that you are able to know. But they only tell us that tension here. Now if this object, this and this, has a tension T and has a frictional force that is more or less like opposing it, that is restricting this object to move forward. It's restricting it to move forward. The moment this thing shifts like this, the moment it shifts to the right, where to the tension is, like it is going where it's supposed to be, it means that the tension is bigger than this and the frictional force. Let me repeat again. If there is a block, normally a block or a mass or an object that is supposed to be dragged by a cord or a string or a rope, the force you are going to apply to it to drag it, when you have the rope on your hand, the moment you have the rope on your hand, the force you are going to apply to it is going to be the force of pull or push. Do you get it? Now that rope or string or cord that you are using, that you are going to use to drag that object or that particle or that mass, now it means that the force that is going to be applied to that object that is going to make it to move is going to be the force of pull or push. Now in that rope or the string or the cord, either of the three, anyone they use, there is going to have something we call tension T. That tension is going to be applied on this. This is air. Now the moment now say that they don't talk about the tension, they don't talk about the force, they only tell us that something is being dragged by a tension of something. If this mass, this object is being dragged, the moment it leaves where it is and changes position, it means that the tension applied is greater than the frictional force. We said that the frictional force is something that opposes the motion, that it is going to oppose this thing, it will not let it to move, and it's even greater than the force of this force of the object. That will now be net force. Now it means that this T will be what? Minus what? Frictional force will be equals to what? MA. This net force. This net force is going to be force equals to net force equals to what? Mass times acceleration. Which is acceleration? Acceleration of the what? Of the object, of this object. So net force net equals to what? MA. So here we have T will now be equals to MA plus FR, which is frictional force, provided that there is frictional force there. Now let's talk about the one that is going up or down, which is what? Vertical. If an object of mass m is drawn like this, is in a position like this, the first thing you must know that this object is going to have something we call net force as well. Its net force is going to be MA, mass times acceleration. And the thing is this: if this were to be mass 2, it's going to be mass 2. If it is mass 3, that's plain. Now, this is going to be the tension in the rope. Now, here, this object, there are two things that's going to affect it. The first one is the weight, which is called mg. The unit equals to what? Newton in N. So mg is in Newton, which is the weight. The second one that's going to affect it is the normal force, or we call it normal reaction. It is also in what? In Newton. But here, the moment an object has a magnitude, you know, magnitude, what I call magnitude is something that has quantity, like 5 kg, 10 kg, or 15 meter, or 25 meter. That's what we call magnitude. The direction is where it is going, okay? Going to north, going to south. I think that's what I'm saying. So here, this thing like this, if the force of Newton is not being mentioned, in most cases, they don't talk about it. It's except some cases, and I'm going to explain those cases to you. The thing is this: tension is going to be applied at T in Newton as well. The moment this object goes upward, it means that the tension is greater than what? Weight and the force not. So the tension T is greater than the weight, and it's greater than what? Net force. Yeah. It means that T minus what? The weight must be equal to what? The force net. So it will now be T minus W will be equal to what? F net. And we note our F net here is what? MA. So this one will now be T minus W equals to MA. So here T will be equal to what? MA plus W. Another one. Now, you know we talk about coming upward. If it comes downward, if it were to be downward, you know this is upward. If it is downward, it is going to be, it means that this weight is greater than this and this. It means that weight is greater than the net force and the what? And greater than what? The tension. The second thing you need to note about this is this. You know this one is in the form of y-axis. When we draw this, you know this is going to be x-axis. This is going to be y-axis. And this is going to be positive y and positive what? X. If it comes down like this, it's going to be negative y. And if it goes like this, it's going to be what? Negative x. In this reaction, in this type of question, you know this one is moving. If it comes down like this, if it comes down, this net force, this object that has a mass, will come down when it is being dragged by the weight, as in the weight is greater. So the tension cannot hold it. So it means that this mass is moving in opposite direction, more or less like in minus y-axis. To the direction of what? The direction of the motion. So we now have, you know, we have W is equals to what? Minus. It's greater than this. Will now be minus T. Will be equals to what? MA. Now, the tension will now be tension minus. Okay, if this one comes here, this one comes here, the tension will be equals to W plus what? Plus, when this one comes here, W minus MA. That's what it means. Now it means that T minus W equals to what? Minus MA. This is the second condition. The reason why I put this minus here, the reason I want to show this minus is that to show that the object comes down along the negative y-axis. That is the reason why. And I hope you understand all this. In this video, I want to explain mass or object that is being carried using an inclined plane system. Let's say this is an inclined plane. Now this one is air. This is the object mass. You know I said that it's going to have a magnitude, and the angle to which this object is being drawn or dragged we are given, and they tell us that this is an angle. They can say 30 degree, 40 degree, or whatsoever. The thing is that, you know, they wanted to use this inclined plane to carry this object up this inclined plane. Let's say they wanted to carry it to a car. In a situation whereby they want to carry rings. Rings, they use rings used in septic tank, or in well. Example like that. You know they are going to place a plank. Across the car, in which they are now going to be like using a rope tie around that ring. After they've used a rope that's been tied around that ring, they are going to like have some set of people that will be pulling it so that the ring is going to like enter the car. Don't let me say car, a pickup. Yeah, a pickup should be very good there. Now here, if this were to be the tension that want to like, this is the tension in the rope that want to make it possible for us to get this mass into wherever we want to take it. This is going to be another what? Force, which is going to be frictional force that will be opposing it, more or less like it don't want this object to go up. You know, we talk about, when I was explaining frictional force, I said frictional force is an object, like it's a force that opposes a motion, directly opposite to it. That's what frictional force is. Now, you know this one, it can happen in a way like this object, it can come down like this. If this plank fails, like it crashes, if this plank crashes, weight is going to what? Have an impact on it. Weight in form of mg. You know, we discuss weight. Now, this frictional force is going to affect it. And this force here that is pulling it, more or less like pulling it, is going to be in force of pull or push. Now, after this, we now want to talk about it in such a way that we are going to know why is this angle affected. Like, how does this angle affect it? Let's now have it in this way. Like we have something like this. Something like this. You know, originally, this angle here will now be what? Theta. You get this W, which is mg, is here. This frictional force is going to be here. And this one, which is what? Force of pull or push, is going to be this. Force of pull or push. Now, let me redraw this triangle. If this happens like this, if you have something like this, this is going to be a right angle triangle. Now, let's withdraw it by having a right angle triangle like this. Let's say I have something like this. You know, this is the hypotenuse side. And this is going to be the side of right angle triangle. And it is here. And anywhere that faces this 90 degree angle is going to be the hypotenuse, which is what? W. This is the angle to be considered. The moment you have angle to be considered, the one that faces this angle to be considered is frictional force. And the one that is air, force of pull or push, is going to be what? Force of pull or push. Or push. This force of pull or push can also be referred to as, in this case, can also be referred to as normal force, which is supposed to be a force, normal force, or we call it to be F normal. I hope you understand what I'm saying. Now, using the trigonometric function, sin theta here will be equals to what? FR, which is opposite, over hypotenuse is W. So our FR will be equals to W sin theta. But don't forget, our W is what? Mg. So we now have Mg sin theta. So our frictional force is equals to what? Mg sin theta. Note this. The second one, cos theta will be equals to what? Adjacent over what? Hypotenuse. What is our adjacent? Force of pull or push. Force of pull or push over what's our what? Hypotenuse. W. So we have force of pull or push will now be equals to W cos theta. And our W is what? Mg as well. So we now have Mg cos theta equals to what? Force of pull or push. Now, I now want to redraw this diagram. Let me now redraw it like this. Let's say this is the diagram. This is a mass. If this were to be the frictional force, it's going to be in form of what? Mg sin theta. From this. If this were to be the tension, and the force that is pulling this upward, that want to make this object or this mass to go into the container we want to use, using an inclined plane system of an angle theta, this is going to be Mg cos theta. I hope this makes sense. Now, how do we solve this? If this force were to be given, if we are given this force, it means that this force of pull or push will be greater than the tension, will be greater than this one. It's going to have its net force. Net force will be greater than what? The frictional force. It means that this Mg cos theta will be minus this tension minus the what? Frictional force will now be equal to what? Net force. So Mg cos theta minus the tension minus frictional force will now be equal to what? Ma. But our frictional force is what? Mg sin theta. We now have Mg cos theta minus Mg sin theta minus T equals to what? Ma. So let me just stop here. You should know, like, Mg is common to both sides, but let's leave it like this. But if this Mg cos theta, like the force of pull or push, is not taken into action, the diagram is going to be like this. They just say that a tension is pulling something. The diagram is going to be like this. Theta. This is the mass. We just have this to be tension alone, and this is what? Frictional force. It means that from here, if this object were to like go upward, to move up, like we are successful with the aim, like wanted to like move this object to a car or something using this inclined plane system, it means this T is greater than the net force here, and greater than what? The frictional force. It means that this T minus frictional force will be equal to what? Force net. So our T tension will now be what? Minus frictional force equals to what? Ma. What's our frictional force here? Because it has an angle, it will be Mg sin theta as applied air and as applied air. So our T minus Mg sin theta will be equal to what? Ma. That's the rule. Now, we want to talk about this. I think this should be case 2. Now, another case 3. When we want to talk about an object that is in this position. In this position, like this. They now say that it has something of this relation, more or less like being affected by a pulley. If this were to happen, you know, this said this is a mass. Let's say this is mass 1 and this one is mass 2. They now say that this thing here is a frictionless pulley. It means that this pulley does not affect the system of this thing. They now say that we should calculate the tension in this rope. In this rope, this is going to be tension, and here tension will be here. And so here, this is where the weight is. You know, I discussed something related to this earlier on. So this one is going to be what? Mg. I hope you understand it. The first thing is that you are going to resolve this the way you resolve horizontal forces. The first one is this. M, like this. They call this one M1. That is the tension T1. So the tension is going to be T1 here. But normally the tension here is going to be the tension here. So for here, if this were to be T1 and this one is to be T2, it means that T1 and T2 are the same thing. Therefore, T1 equals to what? T2. So we have T, the same tension. So here is going to be T1 equals to what? T, which equals to what? M1A. From where I come from, where this place. You know, I talk about this. But if they say it has frictional force, you know, it must have frictional force that is going to be minus from the, it's going to subtract from the frictional tension. Now, we'll stop this. This is going to be the first equation. Now for this, the tension now becomes this. We have object mass 2. This one, now the tension. This one, now the weight, equals what? Mg. You know, they said that this thing, if the moment they have this mechanism, it means that this object is coming down. That's the more or less like the basic understanding of this. Like they are using this mechanism to convey these masses. The moment this one comes down, this one will be coming down like this. Like this mass M will be in position of this mass 2. Before this mass 2 get down, another mass will be here again. So that they are only transferring these masses, this object, using this mechanism. They will be going like this till eternity until it is being stopped. Like this. Like this, and this continually. That's what it means. The moment, you know, this one is more or less like coming down. This is going to be F net, which equals to what? M2A. You know, this one is T, which is the T1 here, which equals to what? M1A here. So it means that the moment this one comes down, we are going to have it to be T minus W equals what? Minus MA. This is what I was explaining the other time when I was talking about the direction in which the object uses to come down. I hope this makes sense. This is what we arrived at. So here, you know that we have this one to be M1A is tension. So we now have M1A minus W equals to what? Minus MA. Here, our W is what? Mg. We now insert it. We now have M1A minus Mg equals to minus MA. But here, this net force is M2. This is a mistake. M2. It will now be M2A. Now, let me tell you one thing. In this type of approach, in this type of question, like the type of question related to this, the acceleration A that's going to come out to all these masses, they are always equal. They are the same thing. The reason is that they are going to be moving with the same speed. You must take note of that. Even if you have 1,000 masses A, or 2,000 masses air that is being attached to this string or cord or what or rope, the acceleration they are going to use, acceleration A, they are always going to be the same thing. I hope you understand what I'm saying. Now, concerning this, let me take this one here and take this one here. M1 A plus M2 A will be equals to what? Mg. But here, this Mg here, it is also M2. The reason that we are dealing with mass 2. So this one will be M2 as well. This one will be M2 as well. I hope this is getting clear. A is common to both sides. You know, I already said that A are also the same thing. They must be the same thing. The acceleration must be the same thing. I'm not talking about the G or the acceleration due to gravity. I'm talking about the A, which the acceleration is not known, but it can be calculated. A into bracket M1 plus M2 equals to what? M2G. So A it now becomes what? M2G over M1 plus M2. So this is acceleration to be used when we want to calculate something relating to this.